I'm one of the science teachers here. We do have a couple other science teachers at Graduation Alliance. So I may be your science teacher, or you may have one of the other ones. It doesn't matter, because what I'm going to talk about today is the same. We all use the same curriculum. So you're all going through the same courses, no matter which teacher it is that you have. And so I'm going over, the lessons and activities that we all share. So that's a good thing. Awesome. Sounds good. Let's get started, guys. Okay, let me show you. Okay. I usually have a little agenda slide here. I apologize. It's not there. So let me tell you then how I kind of break up the live sessions is I first start talking about one topic. So I'm going to spend the first little bit here talking about the water cycle, which is a big chunk. And then after that, I'll have the first of two kind of question sessions. So this is an opportunity to ask questions about maybe your particular course or an activity that you have a question about, that you've been working on, you don't quite understand. Or it could be about, a topic, or it could be about what I talk about right here with the water cycle. So it's kind of an open-ended, you have the opportunity to get that kind of immediate response right here, okay? And then, like I said, I'm going to talk a little bit about rubrics and how rubrics can be helpful. And then I'll end the session again with another question chance for you guys, so you can end your week, be ready to go for the weekend and the start of the next week into science. Make sure you get everything answered. Okay, so that's kind of the layout for how this is going to go. So let's get going. Talking about the water cycle. And we know that the water cycle is one of Earth's spheres. And on Earth, as we're talking about Earth, so we're talking about here, we're in Earth science. And for you guys, that this is maybe your first time joining on these sessions, I usually kind of go back and forth with biology and earth science. And then, if I get requests for other courses to do a live session, welcome. If you're just joining us, we're just getting started here. I can do a live session on that. But for the last couple of weeks, I did kind of a little series on biology. And so now I'm going to go back and hit up some earth science. So that's where we're at. So talking about Earth spheres, we know as we think about our planet, we can break it down into 4 different what we call spheres. And each one of the spheres kind of represents a different part or makeup of what's on Earth. So as you think about it, think about, our planet. Think about what it's like inside, what the surface is like, what it has, what's above us. Hope I'm not giving too many clues. You can also see here in the picture, you can see the breakup of these 4 spheres. These 4 spheres make up the whole entire kind of Earth as a giant system. So we all of these spheres rely on each other. So we think about the hydrosphere, which is what we're going to be talking about with the water cycle. That includes all of the water. And that could be all the water. As you think about, our planet nicknamed the blue planet because of all of the oceans that we have. It could be talking about oceans, but it could also be talking about water that is in the form of ice on the top of a mountain, or the water that's running in rivers. So we're talking about all of the water that we find here on Earth. The lithosphere is the solid Earth. So if you put your foot on the ground, you're stepping on the lithosphere. So we're talking about kind of some people like nickname it the rocky structure or the geosphere. So we're talking about the surface, the solid part of the Earth, including the surface, but it also includes the layers inside of Earth. So again, it's the whole solid part of the Earth, the rocky matter. Welcome. We're just getting started here talking about the Earth spheres, and then we're going to move into the water cycle. Thanks for joining. Then we have the biosphere. In the biosphere, as you think about this little prefix here, B-I-O, we know what that means. You can say it out loud, you can type it in, or you can just think in your head. Bio means life, okay? So, yep, you guys got it. So as we're talking about the biosphere, we're talking about all the life that's here on Earth. So that includes us. But, it also it also includes all the bacteria and all the other organisms and their little habitat, their ecosystem that they live in. The last sphere we talk about is the atmosphere. And that is, you think up above us, think all around us, it's all the gases that we have in our air. Okay, so I like to show this little image because it's kind of nice to see these 4 spheres and how they interact, okay? So as we think about, we've got our lithosphere, the surface, the structure, the rocky structure of the earth. There's our water. We got our biospheres, the tree, the life, and the atmosphere. And everything is connected. So all 4 of these spheres have an impact on each other, and they all rely on each other. Okay, so let's get to, we're going to talk the hydrosphere. So the water cycle. What is it? Think about water. Think about a cycle. The water cycle, which scientists also call it the hydrological cycle, hydro, a little prefix there, is another word that we use for water. So you might, as we think about hydrosphere, hydro, I'm trying to think, drawing a blank on other times, hydration, there's one, I'm trying to think of words that have that hydro in it. Okay, so another word for water. It's it's a type of recycling. So we think about the water cycle and think about cycles in general. It's recycling nonstop. There's not a start point or an end point. There's no finish line. It continuously goes round and round. So the water cycle makes water, which is really cool, a renewable resource. So again, we're not making any more. It's just changing its form and going through this process of being recycled, changing into different forms. So we talk about, well, what are these different forms that water is changing into? You can probably think, as you look at the picture here, a gas, liquid, and a solid. So as you think about, water is found in all 3 of those states, okay? So water naturally exists in 3 states of matter on Earth: solid, liquid, and what we call a vapor, or known as a gas. So think in your mind, where do you see each one of these? This next little fact here, always blows my mind. The amount of water that exists on Earth has always been here, and it never changes. In other words, there's no way to create more water, and there's no way to destroy or lose water. We can't use it up. We can change it, and we can do damage to it, like pollute it and make it into a form that we can't use. But again, the amount of water is here. This is what we have. Pretty cool, huh? Pretty cool for us to take care of it. Okay, so as we think about these different states of matter that we find water in. So here's a quick little simple diagram kind of showing simple parts of the water cycle. And as we think about liquid water, the water in the state of a liquid, we can think about it in the form of rain. Maybe this is an ocean. We can see like a river or a stream. Those are all going to be forms of water as a liquid. Solid, think of the ice on the top of a mountain. And then as we think about a gas is going to be evaporation, in which form water molecules turn into a gas and they rise up into the atmosphere. So you might hear maybe on a weather forecast, or maybe you see on maybe like your phone app or something if you're checking the weather, and it talks about humidity. We're talking about, the amount of moisture or water that is in the air, and it's, as a gas. Okay, so let's look at these steps of the water cycle. The biggest point, as we said, is it doesn't begin. There's not a start point or an end point, but there's one little small piece we didn't discuss, and that's the sun. The water cycle begins with heat energy from the sun. So we have to have kind of some type of an energy source that starts the cycle in motion. And when you think about it, think of, like a car. To make a car run, you need gas. To make our bodies run, we need fuel. And so we get this energy from the sun. Think of the sun shining down on our planet. That's the kind of the beginning steps, or the energy, the power source behind the water cycle. So as you think about what happens when you see the sun shining down on Earth, I always like to think about, like in the summertime, maybe if you spilt something outside, like a cup of water outside, or you washed your car, and there's all this, you can see the water on maybe the cement, and then over time it dries up and it evaporates, and that's coming from the sun. The sun's rays warming up the surface of the earth. Okay, evaporation. Evaporation is the process of turning water from its solid form into a vapor, which then rises up into the atmosphere. This water vapor is nearly invisible to the naked eye. I gave you a couple examples when we can see it. When the sun heats the earth's surfaces, it can cause water to evaporate. Okay, so you've probably seen this whenever you have made some noodles or something on your stove, and you've boiled, and you get to that point where liquid water starts steaming as it boils. That steam is water turning into a gas. So it hits a point in time where the molecules are moving so fast that it changes state to a gas. And you can see here, we've got you can see the moisture on the top of this lake. Okay, so evaporation is when the sun's energy beating down on these bodies of water, heating it up, causing those water molecules to move really, really fast. Liquid then becomes a vapor, and it goes up into the atmosphere. It's still water, just moving, it's transforming. Transpiration, it's kind of like evaporation, except for transpiration. Transpiration is the evaporation of water as it's released through pores in the leaves of plants. As we talk about in photosynthesis, we talk about one of the byproducts or a product of photosynthesis is water. We also get that in respiration. So think about these tiny pores, like pores in your skin. It's kind of a way that the plant breathes. And as it's breathing out, it's giving off water. So water is coming out of those pores. We do it the same. If you think about, sweating out your pores. Okay, as that water is released, it evaporates up into the atmosphere. Sublumination, this one is kind of a hard one because we don't see it firsthand quite often, but this is the process of water turning from a solid, so think of ice or snow, and it goes straight to a vapor. So it's, usually we think, wait, the snow and the ice has to melt first and then it becomes a gas. Well, it skips a step. This goes right from solid to a gas. Okay, the vapor also rises up into the atmosphere. This occurs in really extreme coldness and dry climates, such as high up in the mountains. Okay, condensation. We've all seen this before. So think about, we've talked about, first we had kind of the sun giving us this energy, and then we talked about liquid evaporating and becoming a gas. Now think about all of this water that we have in our atmosphere now. It's evaporated up. What does it do? Well, it condenses. So condensation is when water vapor turns back into droplets of water through a process called condensation. This also occurs in clouds after they are formed. So you've seen this before, like when you take a shower or in the morning early morning, cold mornings, you can see, beads of dew that occur. Okay, so the water that is in the air or in the atmosphere, it gets heavier and heavier the more water that is getting put up there. Eventually what happens is molecules attract to each other. And so water molecules, they want to stick together and they start combining and combining and condensing and condensing and condensing and making these droplets. I always think of like a windshield, when it rains on a windshield, and you'll start noticing that the droplets of water, they kind of bead together. They're attracted to each other. They're condensing. Okay, so that's what's happening up in our atmospheres. We're putting, as water is evaporating as a gas, goes up in the atmosphere, and then those molecules start condensing again. And it gets heavier and heavier and heavier, and of course we get precipitation. So as the water droplets accumulate in the clouds, they become heavier and heavier, and in time, gravity takes over and those droplets fall to the earth in the form of rain or snow, or I'm sure maybe hail, sleet, all the other wonderful weather that we can get. And we call this precipitation. So again, as that water condenses, as water molecules are condensing, getting heavier, gravity is going to pull it back down to earth, and it falls in the form of precipitation. Pretty cool. Runoff. Okay, so we've got precipitation. It's coming down. Well, what happens? You know, rain and snowmelt that are pulled downhill. So we got gravity working on us here. It becomes runoff. And eventually this water makes it back into the ocean where the cycle kind of starts again. Again, we talk about a cycle. It's never ending. It's continuous. It keeps going. So you can think of maybe if you live around mountains, you know, you see this in the springtime as the snow melts, our rivers, they get like this. We get all of this runoff from the snow melting, and it kind of creates these deeper, wider, heavier flowing rivers. Okay. You might also know this with if you live in an area that has like irrigation runs. You can see that after a rain, you'll notice that kind of all the water that precipitated down, it kind of files in and it finds its way into a larger body of water, kind of going from like a canal into a river. Okay, so we got that runoff. Eventually it gets to the ocean or a bigger body of water. Infiltration goes along kind of with runoff. So not all the water from rain flows from the Earth's surface as runoff. In those flat areas of the Earth where the water kind of pools and collects, it's going to seep into the ground. And this is called infiltration. So you think about that infiltration. Infiltrate, going down. Infiltration allows large underground lakes and rivers called aquifers to fill up once again, which are pretty useful. This is a source of what we call or use as groundwater. So you think of, if you know anybody or maybe yourself or you heard, somebody has like a well. And so we're thinking about they're digging into the ground and they're finding these aquifers of water that runs underneath the land, and that's from infiltration. You can also see this, you know, if you're watering a plant and the soil is really dry and you pour some water on it, you'll kind of see the water kind of pools for a minute and then it slowly seeps into the ground. That's infiltration. Okay, so that's the major parts of the water cycle. And again, it just keeps going and it just keeps going round and round. No stopping point, no ending point. The sun, some big reminders here again, the sun is the driving force of the water cycle. Without the sun, we wouldn't have that power or that source to make it occur. So we wouldn't have the start of this, you know, evaporation occurring. Okay, so here as we can look in this picture, can kind of see the different stages that are occurring. So of course we start with our sun. Here's our energy, okay? The sunshine beating down on the water. It's causing those water molecules to speed up. And as they speed up, they move upwards and they begin to evaporate and become a gas. Those water molecules move up into the atmosphere where they kind of condense, where we get condensation. They group together, it gets heavier and heavier and heavier, and soon enough gravity pulls it back down to the ground as precipitation. That precipitation is going to kind of pool and collect together, and it's going to run down into streams as runoff. Okay. Two other parts in there that three that we didn't talk about. Transpiration. So again, transpiration comes from plants. So it's the evaporation of water in plants. And then infiltration, like runoff, the water seeping into the ground. And then sublumination is going from that solid to a gas. Pretty cool. What do you guys think of the water cycle? Now you know. It's amazing to think that all of these, you know, these awesome cycles are occurring on Earth just naturally. And it's just a process of how it works. And we don't even think about it. It just happens. It's a lot. It is a lot. Hopefully I broke it down. I tried to give you, you know, just the main parts, try to give you some examples that kind of help you get going. I like to use the pictures because again, it kind of helps show. I think a lot of times students struggle with the water cycle because they're like, well, where do we start? What's the next step? And sometimes, you know, they're like I'm talking about, the water cycle doesn't have these hard stops and ends. Again, it's a continuous cycle. And sometimes, you know, it'll take a different form. So again, it's just thinking about the different steps. The biggest parts to think about, you know, is the sun is, you know, you got to have that sun. Sometimes it's confusing, totally. I get that. So thinking of it in pretty simple terms, okay? We've got the energy, the sun. Think of the sun starts it out. We've got the energy. Think of the sun's rays are beating down on the earth or beating down on this water. As you guys all know, you know, when things get hot, you know, it's going to cause evaporation. Those water molecules are going to move up into the atmosphere. Eventually, they condense together. They get heavier. They start bonding, beating in together. And then those water molecules get too heavy and gravity pulls it back down to the earth in the form of precipitation. Think about water. Water likes to run together. We get runoff in the form of like a river, a stream, a canal, pulling that water back down. So gravity is also here working. Okay, so those are the big steps as you get the sun's energy, evaporation, condensation, precipitation. The other ones that we talked about, sublumination, runoff, or sublumination, transpiration, and infiltration, they're all forms of, like infiltration is a form of runoff, transpiration is a form of evaporation. Okay, so again, the big ones, sun's energy, beats down on the water, we get evaporation. Those water molecules condense, condensation occurs, we get precipitation. And it goes round and round. Okay. Any questions about that? Okay, that's my little wait time. Okay, again, the water cycle, biggest thing, there's some questions I see in that unit, and I think kind of trick students up is, you know, what's the driving force behind the water cycle? I feel like I've said it over and over to you guys, it's the sun. So the sun's energy is what puts that water cycle in motion. So the energy source for the water cycle is the sun. Okay, that is my little presentation on the water cycle. Does anybody have any questions about a topic that you're working on or an assignment? This is an opportunity. Again, you can type out a question that you have, or you can unmute yourself if you're muted and just talk out loud. So if you want to get, you know, a response to a question or a little bit more information, I can answer that now. I'm gonna wait just a moment here, make sure everybody has a chance. I will open it up for more questions at the end of the session as well. So if you're still thinking about that question or how you want to word it, keep it in your mind. At the end of the session, I'll ask if you have questions as well. We got a question. The cycle is always on. Would it be possible that we never run out of water? Is it possible that we'll never run out of water? Is it possible it's possible that we can run out of clean water, but it's not possible to run out of water. So as we talk about, the water cycle is always going. It's continuously going. We can change kind of the amount of waters in each state. So you might hear people talk about rising ocean levels or polar ice caps or glaciers declining. So we can change kind of where the water is in each state, but we can't destroy the water. It's always going to be somewhere. We can destroy it for ourselves by polluting it. So people, you know, a lot of people say, well, it keeps raining, like we keep getting snow. What are you talking about? We're always going to have water. We are always going to have water. But the problem is that water going to be clean? Is that water going to be okay for us to use? Is it going to be okay for plants to use? You know, that's our concern with water, is running out of clean, usable water. Good question. Okay, so I want to talk a little bit about using a rubric. This is coming from Unit 5 and Unit 6, and there is an activity called Follow the Job. So I want to use that activity as kind of an example of showing you how to use a rubric. But, you know, I'm sure in your classes and also in science, you've seen the rubrics built into the assignments that you have, and they are important and so helpful to you guys. So I hope that you're using them. Okay, so let's talk about what is a rubric. Do you guys like them? Are they helpful? As we think about what a rubric is and its purpose, you know, the purpose can change depending on what role that person plays. So a rubric can be helpful for, you know, a teacher, and it can also be helpful for a student. Yeah, it depends on the subject for sure. A rubric kind of gives you kind of like the criteria that you need. Like, what do you have to do to complete this assignment? Kind of gives you the directions, but it gives it to you in a way that kind of lets you check yourself off and say like, okay, I hit this, I hit this, I hit this. So rubrics are simply a scoring tool. So it's a tool that teachers use and students use to figure out, you know, well, what did I get on this assignment? What's my grade? We got another little chat here. Thanks for your comments, guys. We appreciate it. I think when you think about a rubric, you think of Fitbit. So with Fitbit, it kind of shows you what you need to do for the day. Is that what you're talking about? Like, I need to get this many amount of steps, this much. Yeah, gotcha. Yeah, it kind of helps you kind of symbolize things and say like, okay, this is what I need to do to meet the requirement. Awesome, good example. Okay. So we can use it, like you guys have just seen, in daily life. We can use it on projects, rubrics, other pieces of work. So you could think about like if you're performing a dance or playing a musical instrument, you can use a rubric as well as a scoring guide that gives you the criteria of what you're being scored upon. Rubrics list what needs to be included in order to receive a certain score or a grade. It allows the student to evaluate their own work before they submit it. Instructors can then justify, you know, the grade based on using the rubric. So it's a great scoring tool for everybody. I always tell students, you know, when they're going back and looking over their work, you know, take your rubric out, grade yourself, go through each criteria and then look at your project and say, did I do this? Did I do this? You know, check it off. You can evaluate yourself the same way a teacher is going to evaluate with a rubric, because it's telling you exactly what the criteria is. So everybody, there's no kind of gray area. Oh, I think the teacher wanted this. You know, with a rubric, it tells you, list, you know, give 3 pieces of evidence. Okay. I always like them because, you know, it makes it easy to score, but then it also, you know, it lets the student, lets you guys know, you know, what is my expectation? What is expected from me? If I want to get 100% full credit, an A on this project, what do I need to do? And then you look at the, you know, exceeds the standard, and that's where you want to be as you go through and you create your project. Okay. Let me see if I can make this a little bit bigger for you guys to see. Okay, so different parts of a rubric, they can look differently, but they kind of have 3 different parts. You've got kind of your learning standard or your goal. And so it could be a discussion. And that's going to kind of be like the directions. You can take out what the learning standard is or the goal in your directions. You'll usually say, in this assignment, you are going to play the role of the molecule and travel through the water cycle. Okay. The next part is you're going to have criteria. And in that criteria, it's going to have what it is that you're being assessed upon. So what you need to include. Okay. So criteria could be lists all the steps of the water cycle or includes all the steps of the water cycle. It could include something about, grammar and punctuation, uses correct grammar, correct spelling, all that. Okay, so again, the criteria is the parts of the project that you need to work upon. I know in another lesson, there's an activity where you do a presentation. Welcome, we're just talking about rubrics here. There's a presentation that you do on a particular biome, and I know some of the criteria is, it lists off like, describe the characteristics of the biome is one of the criterias. It talks about, list abiotic and biotic factors in the environment. Also has a criteria for pictures, and of course grammar. So again, that criteria is, what is the expectation? What do you need to include in this project or assignment? Okay, and then within the criteria, so you got here, this one talks about, this is on a discussion, it talks about frequency of participation, the quality of ideas, spelling, punctuation, and ideas, and grammar, sorry. And then you got kind of the descriptor, and the descriptor is gonna be the points that you earn. And we usually set it up into kind of columns that give you, exceed standard, meet standard, does not meet standard. So it kind of gives you the breakdown of those point values. So if you exceed the standard, that means you met, all the criteria. And it will say in the criteria what it is you need to do. Let me show you. Let me show you the one for the water cycle, okay? So here you can see it gives you the point values, okay? So as we're looking at our criteria, and here we've got the steps of the water cycle, correct punctuation, and then it talks about the parts of the water cycle, so actually using the vocabulary in it, okay? So those are our 3 criteria, and then we've got descriptors in each one that give you a detail about what it is that you need to include. And then you can see in there as well the scoring, okay? So if you want to make those full points, get the full credit here, you need to make sure that you're in that exceed standard category. And so you'd want to look at, in your project, did you meet this criteria? Okay. And then as you can see, you've got meet standard, does not meet standard. Okay. So it kind of takes, the rubric takes it from full points to, okay, maybe you did part of it, so you're gonna get some points, to maybe you didn't do it, or it wasn't correct, to no points. Okay, so let's go to follow the drop. Again, this is activity 4.4.2, follow the drop, okay? And it kind of takes, what's fun about this activity is it takes away from, kind of, you do a lot of, you have some assignments along the way that are kind of check-in points. So you might get some true and false, multiple choice, kind of like quick little, informal kind of assessments to see where you're at, check in that you've got the information. Well, here you're kind of doing an application, which is fun. So they're asking you to take kind of a creative point approach to the water cycle. So follow the drop. In this activity, you will identify the different steps in the water cycle by playing the role of a drop of water. You're going to tell the story of what it's like to be the drop of water moving through the water cycle. Break down the steps in the water cycle, step by step, and describe the sequence of events that takes place. Summarize the benefits and results that occur over and over again as a result of the water cycle. And then, it puts it in here. It's your choice. You can play a water cycle from ancient past, dinosaurs, or, a droplet that's coming out of your water faucet right now. However it is that you want to play this, okay? So here, our goal is to identify and describe the steps to the water cycle by playing the role of a water molecule. Pretty cool, okay. And it gives you a little bit more information because you are the drop of water and it's your story. You can choose where you want to begin your journey. Maybe you want to begin at the top of a mountain. Maybe you want to be a water molecule in the ocean waiting for the sun to evaporate you. Okay. So this just gives you a little bit more. Remember that since the water cycle is continuous, wherever you start is where you're going to eventually end up again, making sure that you're hitting on each piece of the water cycle. Be creative and be sure to include all the steps in the water cycle. Refer to the rubric in the drop-down box at the top right of the screen to see how this activity will be graded. Okay. So they kind of give you the directions, and then it goes to the rubric here. Some people see that, and first thing is they say, I'm not a good writer. I'm not good at being creative. I know for me, sciences math was always my strong point. And so when a teacher would like write a story, I was like, oh my goodness, oh my goodness. But what's great here is if you look in this rubric, do you see anything in the rubric saying you're being graded upon your creative abilities? No. Okay. So on one hand, you know, this is taking it if you love to write and you love being creative. This is awesome for you because, yeah, you get to run with it, create the story about a water molecule. On the other side of it, if you're like, oh, can I just tell you the steps of the water cycle? You know, of course you can here as we look at this rubric. But please know you're not being assessed on how creative or well-written your story is. As you also think, I get questions, well, what about length? There's nothing in the rubric that talks about length. You've got 3 criteria, 3 categories that you're being assessed upon. So to meet the standard of this assignment, it says the steps of the water cycle are included and explained. So as you're going through your story, you are telling correctly the steps of the water cycle as you're going. Now you can decide, like we said, you can start where you want. You can be, you know, a piece of ice, or you could be a water molecule up in a cloud. It's your choice. Okay. The next category, correct punctuation, paragraph, and grammar are used. So make sure you guys, I see lots of times I'll see capital letters not there. Please try to use correct punctuation as you're completing your assignments, okay? So you want to start with capital letters. Make sure that you're ending with, you know, whatever punctuation that you need. If it's an exclamation point, question mark, or a period, make sure that that is being used, okay? And then the parts of the water cycle are used. So you want to make sure if you're looking to meet this full credit here, you want to use evaporation, condensation, precipitation, transpiration, sublumination, runoff, and infiltration in your story. So like the picture that I showed you, you would want to take the time to write about your water molecule going through each one of those stages. Okay. And those are the 3 parts of the rubric. So after you go and write your story, and you can look at your story and you can assess yourself right here. You know, you read your story and say, the steps of the water cycle, are they included and explained? So did my water molecule move correctly through the stages of the water cycle? And did I explain it somewhat? Did I not just say, first I was precipitation, then condensation? Because that is not an explanation, right? So that's going to get you down here. Okay. And then you would look at your story. Did I use correct punctuation, grammar, spell? Hopefully you got, you know, spelling check can help you with that. And then the last one, all parts of the water cycle are used. So did you hit upon each one of these? Okay. Maybe if you only talked about, you know, the big 4, you're gonna, as you can see, you're gonna move down the point value a little bit. Okay. Well, let's take a look. So this is an example from a student. Okay. So this is an example of what they said, and I know, I'm sorry, putting it up on the screen, it kind of is like, oh, those are a lot of words, lots of letters, so bear with me. Oh, hello, you've caught me during my evaporation. What is it, you ask? Well, it's when water from an ocean, lake, or river, or some other body of water is turned into a gas. Oh, here we go. It's cool. It's quite getting evaporated. You know, one of the funnest parts of the water cycle, like riding on a cloud. What? You don't know what the water cycle is? Well, let me put it this way. It's kind of a journey of water. Then I go through the process of condensation, where I turn back into liquid inside a cloud. Kind of gives me this rumbling in my tummy. Oh, now we're getting into the fun part. The next process is precipitation, where I fall down from a cloud. Oh, and here we go. Now I'm in the form of rain, and sometimes when it's really cold, I turn into snow. I'm about to hit the ground now. Sometimes I land on an umbrella, which I like better than just standing straight plop on the ground, landing straight plop on the ground, because you get to roll down the umbrella, and there's one now. Whee! Now when I'm on the ground, 4 things can happen. It can either become runoff water, where I'm pulled downhill by gravity, or I'll be on flat ground and seep into the ground as a process called infiltration. And I'll be dropped into underground lakes or rivers called aquifers. Or I will fall on a plant and stay there until I'm evaporated through the process called transpiration, which is evaporation, but I'm evaporated from plants. Or I will fall onto a mountain and freeze. I much prefer to be runoff water so I can be like a water slide. Whee! In the case that I'm runoff or water in an aquifer, I meet back up with the ocean eventually. Or I'm frozen on a mountain. I go through a process called sublumination, which is basically solid turning into vapor without passing through that liquid stage. Anyway, it happens though, I always start the water cycle over again. I like meeting back up with the ocean the best. Well, I hope you had fun learning about the water cycle with me. I sure had fun. I'm just gonna sit here and wait till I get evaporated, and here I go. See you later. What do you guys think? This writer, they had fun with it. They got creative. They were telling a story. I was digging it. Okay, so let's take a look at that rubric. I know it's kind of hard to go back to all that we saw. So as you think about, if we were to assess that piece, let's look and see, were the steps of the water cycle, were they included and explained? So did they have a start point and kind of an ending point where they made the whole cycle? And then of course talked about, well, I'm gonna keep going. Did you guys hear that in that story? Also, when they explained it, if they explained it, did they actually say like, well, what is precipitation? What does transpiration mean? How do you think that student did? Yeah, I agree. Yep, they gave us kind of the starting point and kind of an ending point of making this huge cycle, but they also said, like, hey, it's not over, I'm gonna keep going again. And I liked it, that they gave descriptions. So they talked about, well, what is precipitation? I'll tell you, and then they explain what transpiration is. So yeah, I definitely think when we were thinking about there, they included the steps, kind of summarized what the water cycle is, continuous cycle, it keeps going, and they explain the different parts. Correct punctuation, paragraphing, grammar are used. What do you guys think about that? Did you catch any little errors? I think for the most part, it was, it was good. Of course, I think there was a couple little like missing an A or maybe spelling on one of the words, but I really feel like, it wasn't anything that I think we would go down to just kind of meeting that standard. I still felt like the student gave good punctuation. I liked, having the exclamation points to make it into this, creative story. Yeah, I hear you. I'm not good with grammar. I'm still learning on with that too. And I even just took a grammar class not too long ago. Yeah, whenever they explained it well. Yeah, see? So as we can say, and what looks here is in that criteria, we can look at, 1.5 to 3. So, maybe if we can't say like, oh, it was 100% perfect, maybe we could drop down, a little point value or something, but still keeping it with that exceeding that standard, meeting the parts. Thanks for your input, you guys, I appreciate it. And then all parts of the water cycle are used. So did you see evaporation, condensation, precipitation, transpiration in their story? Yeah, they did a good job of hitting all those different parts. And I like the part where they talked about, the difference between runoff and infiltration and transpiration and evaporation. I like those connections that they made there. So again, you can see, there's definitely here in this exceeding that standard, meeting those higher point values for that scoring. So again, when we talk about rubrics, they're great because of course they let you see what is it that I exactly need to do to get the points. And it's a great tool because it allows you to then take a look at your work when you're finished and do a little self-assessment. Like we just did with the student story that we just read. We can come back and we can, you know, quickly go through it ourselves, and we can pretty much see what it is we're going to get. And from that, you know, you can take that reflection and say, okay, am I happy? No, maybe I need to add a little bit more to this criteria. Or you can say, okay, I'm good to go. I'm ready to submit it. Okay, so I like using a rubric because of course it allows you to know exactly what you need to do, how you're going to be assessed, and then of course it allows you to critique your work and look at your work before you submit it and say, did I meet all of the parts? Like it. And then of course from a teacher's perspective, when I get your assignment, I can quickly use the rubric and say yes or no, or yes or no, and I know, you know, there's no kind of gray area on what the point values are because the rubric lays it out for us. So again, as we think about using rubrics, they are a great tool for everybody to use. So when you're thinking about, as you're getting into these assignments and activities, take a look at those rubrics and make sure that, you know, you're using to the best advantage that you have, because they're helpful. Okay. When I hear that question, well, what am I supposed to do? Let's look at the rubric. It tells you. Okay, guys, that's what I have today for the water cycle and rubrics. Questions? Okay. I'm going to keep talking, but if you have a question, go ahead and get it in there. But also, when we're talking about questions, you guys, your teachers are here to help you, okay? So if you're stuck on something, or you're not sure about how to complete it, or there's a topic that you just don't get, please reach out to your teachers. I never like to hear anybody say, oh, I'm frustrated, I just don't get it. You know, keep that motivation, keep that learning going. Your teachers are here, so send us a chat, send us an email, whatever kind of mode of communication works for you. Quick little question, we're right there to help you guys, okay? So again, please don't ever go on thinking like, oh, I just don't get it, what am I supposed to do? Send me a message, I'll explain it. And also I think, you know, sometimes having somebody else just explain it out loud, or explain it in different words than maybe what you see in your course can make all the difference, okay? After this session, the recording will be, a link will be sent out, and it will go into, we have a YouTube channel where you can view all of the collection that we have of all of them. Yep, so that you can access them later, and you can also see all the other ones that we have been doing, okay? There he is, thank you. Okay, so there's the link, which is awesome. I always like to go in there, and I like to watch some of the videos as well and see what's going on. Okay. As we're thinking about next live sessions, if you have a topic or an assignment or a project that you would like to see, please let me know. I would love to take your input into this and make it into a live session to help you out, okay? Yep, there are playlists. Yeah, it's really, really handy, nicely laid out, okay? So looking ahead to next week, again, if you have ideas about what would be a live session topic, or a little bit more, maybe a skill you'd like me to go over, I would love to do that for you. So keep in communication, keep in contact. We're here to help you as well. But thank you everybody for joining. And again, I'll be on next week as well. And so if you have questions, bring those questions, because as you saw kind of the layout, we've got those 2 little periods where I will take questions for you. Thank you so much for joining today. Oh, so sweet. I hope this was helpful to you guys, or kind of nice to see how a live session goes if you've never joined one. So have a great day, you guys. Again, if you have a question, send me a chat or an email, and I'll be sure to help you. Okay, happy Friday. Have a good weekend. Keep science going. Bye, guys.